Let ABC be a right angle triangle with hypotenuse BC of length 20 centimeters. If AP is perpendicular on BC, then the maximum possible length of AP in centimeters is. Now let's try to draw a figure over here. It is given that BC is a hypotenuse. So the right angle is A. From A, we have a perpendicular at point P on BC. Now let's assume BP as X. We know that BC is of 20 centimeters, so therefore PC will be 20 minus X. Let's assume AP as P. Now, if we consider triangles BPA and triangles APC. Now, if I assume that this angle is theta, angle ABC. Now, it is also ABP for this triangle. Now, if you consider this triangle BPA, I can say that angle BAP is equal to 90 minus theta. And over here, angle ACB will also be equal to 90 minus theta. Now we have assumed angle ABP as theta, and over here angle PAC will also be equal to theta. And therefore we can say that triangle BPA is similar to triangle APC by angle AA test. Now BP upon AP is equal to BP upon AP is equal to AP upon PC. Now BP, substituting the values, we have X, AP is P, is equal to P upon 20 minus X. So we have here P square is equal to X into 20 minus X. So this is the relation between P and X which we have got. Now over here, we want to get the maximum possible length of AP, and therefore it should be the maximum possible value of P square as well. Now product of two numbers of two things will be maximum when they are equal. Okay, and therefore it has to be X is equal to 20 minus X. So minus X comes over here, we get 2X equal to 20, and therefore X equal to 10. So P will be maximum when X equal to 10. So if X is 10, this becomes 10 into 10, that is 10 square. So therefore P also, we have P square equal to 10 into 10, and therefore P also comes as equal to 10. And therefore the answer is option A.